Okay, here we go into lesson 3.7, tangent line approximations and differentials. So sometimes this is also called local linearization, right? But those are tangent line approximations. This is sometimes covered in a non-AB or BC calculus course, but mostly this is covered in AB and BC calc. Let's dive. So use the tangent line to f of x equals 0.5x squared at 1 comma 0.5 to approximate f of 1.4. Whoa, it's a mouthful. So let's just first start with the tangent line to this curve at that point. So we need that. So let's find it. So if we want the equation of a tangent line, and if you need help remembering how to build those, go back to chapter 2. Right? We do a lot of that in chapter 2. Y minus y1 is equal to m times x minus x1. I always start out with that template, right? It kind of gives me the ingredients I need to plug in. Now we have our points. This is x1 and y1. But what we still need is the slope at x equals 1. So let's just find our tangent line. We'll worry about the approximation part shortly. So we need our slope to find what m is. So f prime of x, very simply, is 2 times 0.5, which is just 1. So it ends up being x. Very simple derivative. So what is the slope at x equals 1? Well, that would be f prime of 1. Just plug in 1 there, and so your slope is 1. So the equation of our tangent line is y minus 0.5, not so bad, is equal to the slope, which is 1 times x minus the x value of 1. So that's old school. Right? We did that in chapter 2. Not so bad. But what is this whole approximate business? Well, if we think about it, this tangent line, let's actually draw it on the graph to see what we're going to do to approximate f of 1.4. The tangent line of y minus 0.5 equals 1 comma x minus 1. Well, that's at the point 1 comma 0.5. Well, that's right here. That's point 1 comma 0.5. And I zoomed in on it here to explain a little bit more. So you're taking a tangent line and you're using it to essentially approximate the value of the curve at, and I'm trying to draw this as straight as I can, at 1.4. This is 1.4 right here. So what we're essentially doing is we're saying, let's find the y value here on the tangent line, and that will approximate what the value is on the actual graph. That's what we're going to do. And I drew that one a little bit closer here so you could see it. So this is the point 1 comma 0.5. This is the point 1.4 comma whatever we get when we plug 1.4 into the tangent line. It's going to accomplish an estimate of this 1.4 comma whatever that value is. Okay, so how do we go about doing this? It's actually very simple. At this point, if you want to approximate f of 1.4, that's the y value on the tangent line. So f of 1.4 would be equal to, or I'll say approximately is equal to, because we're using the tangent line to approximate it, 0.5 plus, and you might be like, where's that 0.5 coming from? I'm adding 0.5 to each side. I'm solving for the y value, and y is f of 1.4. So I've got 0.5 plus 1 times 1.4 minus 1. It's as simple as that. We're just plugging x equals 1.4 into the tangent line, and the y value we get on the tangent line will serve as the approximation for the y value we'd get if we plug 1.4 into there. So we get 0.5 plus, this is 1 times 0.3, and that then ends up simplifying to 0.8. So that's the approximation. So therefore, f of 1.4 is approximately 0.8. And you might say, well, okay, what's the purpose of doing an approximation when we could easily plug 0.8 squared into this function, right? 0.8, square it, and multiply by 1/2 and get the exact value. The purpose of this is to show you the idea of how we can use tangent lines to approximate values on a curve, but to do it with a curve that is not so gnarly. So when there's square roots or rational functions or something that's really heavy, this actually comes in pretty good handy. And again, you might ask, but I've got a calculator for it. Well, down the road, this idea of a tangent line approximation is going to be built upon. But that's it. That's all we're doing. One more time. Find the tangent line, plug in the x value into the tangent line where you want the approximation. You're then finding a y value on the tangent line. That approximates a y value on the curve that's near it. So we got this value and it approximates this. That's it. Okay, let's keep rolling. So on to the next bit. I want to go over, for those of you that are expected to know this, when is a tangent line approximation an over or an underestimate? It all has to do with concavity. So if we take a look at this, let's say we have a curve that's concave down on an interval, and we're using a tangent line to approximate, I don't know, any point on this interval here. Any point on this line that you pick is going to be over the curve. So we'll do an over approximate. Here you see we're also concave down. Any point on this line is going to be above the curve. So we're going to be an overestimate when f double prime, right, when concavity is down, f double prime is less than 0. It's as simple as that. So don't memorize it, draw out the pictures. When you're concave up, your tangent line approximation will be an underestimate. You can see the line and all of its points are below a curve when the curve is concave up. And that doesn't matter if you're concave up and decreasing like here, or concave up and increasing there. So when f double prime is greater than 0, it's an underestimate. Don't memorize it, see it in the drawings. So in this previous problem, we know that since the derivative of this, if we write it as f double prime of x is equal to 1, which is greater than 0 everywhere, that means we're concave up the entire time on this curve. So this tangent line approximation at 1.4, since we're concave up from 1, where the tangent line starts, to 1.4, where we're approximating, all these points will fall below the curve. So we know that 0.8 is an under approximation of the true value we would get if we plugged, well, 1.4 into this function. That's it. Not bad, right? Not bad at all. Okay, let's keep rocking and rolling. On to the next part. So, last little piece here. Use the tangent line to f of x equals x cubed minus 1 at x equals 2 to estimate f of 1.9. All right, let's just start there. So again, we need our tangent line equation. That's going to be y minus y1 equals the slope times x minus x1. So this is x1. So how do we find y1? Well, we're going to have to plug in 2. F of 2 is equal to 2 cubed minus 1, which is 7. So now I've got y minus 7 is equal to the slope, which I don't know. All right, so we're going to have to find the slope, but I at least have x minus 2 here from this. F prime of x is going to be equal to 3x squared. So f prime of 2 is equal to 12, right? 2 squared times 3. All right, so we've got our tangent line equation. So how do we estimate f of 1.9? Again, what you're essentially doing is you're just plugging in 1.9 in for x. So I got 1.9 minus 2. So I'm going to solve for y. So that y is an approximate of f of 1.9. Which is approximately, we add 7 to both sides, 7 plus 12 times negative 0.1. And if we simplify this down, that's going to be 7 minus 1.2, negative 0.1 times 12. And 7 minus 1.2 is 5.8. So f of 1.9 is approximately 5.8. Okay, so as far as our curve goes, we see that it's concave up just visually right here. So we know it's going to be an under approximation, but how do we justify it formally? Well, let's find the second derivative, because it says here, is your estimate an over and under approximation? Well, since f double prime of x equals, let's do this out, the derivative of that, 6x, which is greater than 0 over x equals 1.9 to x equals 2. It's the interval over which we're concerned between where we're approximating to where we're actually drawing the tangent line that we care about. So since the second derivative is greater than 0, we're concave up from 1.9 to x equals 2. Then our approximation, well, draw it out if you need to. Concave up, our approximation is an over approximate. Then our approximation is an over estimate. That's it. And that's a formal way of defining that. All right, y'all, that's all. Some good videos right there. Very quick problems. Figuring out the equation of a tangent line and using it to estimate a value at a point is not too difficult. It's important you understand it visually. And then that over or under estimate will come up in AB or BC calculus, but not necessarily in a college calc course or in another kind of high school calc course. I'll see you in the next one.